Good morning everyone, I am Mr. Ish. Thank you for joining me for this video where we are examining a single problem, a high school level math physics style problem, an important one because this type of question serves as a source of confusion for many students. The question is this: how fast must you throw a ball straight up in the air to reach a maximum height of 50 meters? Again, how fast must we throw the ball straight up to reach a maximum height of 50 meters? What are we asking for? How fast to throw? We're looking for initial velocity. And that's what we need to determine. What is that initial velocity? You're looking at a situation where from the ground you're throwing a ball straight up, it will reach a maximum height before it will turn around and come down. This right here is your maximum height. You need to understand what happens at this very top part in terms of velocity. You're throwing a ball with a certain initial velocity. As the ball comes up and it turns direction, at that specific point your final velocity, because it's going to turn direction and come down, will be 0 meters per second. You must understand that, otherwise it would be difficult or if not impossible to answer this. Remember, as the ball is thrown up with an initial velocity, it will reach a maximum point after which it will change direction and come down. At that maximum point in terms of velocity, it will be 0 meters per second. The ball will actually stop right there in air for a brief moment in time. Everything over here is with regards to vectors, their magnitudes and directions, so you don't want to be ignoring the vector aspect. You know acceleration in all instances basically minus 9.8 meters per second, same thing as gravity, it's synonymous. You want to look at these two equations. Final velocity is equal to initial velocity plus acceleration times time, and your position of an object is equal to half at squared plus vot, initial velocity times time, which sometimes can be broken down or trimmed down into this part. S is equal to half at squared. In all instances, the acceleration can be synonymous with the gravity value g. They're both the same. A and g would be the same. How would you go about proceeding with this question? And trust me, it's not hard. You just think it through. The first thing you want to do is bring this into the picture. At maximum height, the ball is 0 in terms of its speed. 0 is equal to your initial velocity plus acceleration minus 9.8 t. Why am I doing minus 9.8? Because acceleration or gravity are always downwards towards the earth. The vector direction is always downwards with regards to acceleration or gravity. VO over here is equal to 9.8 t. That's a factor we can keep in mind. Now, how do we know which equation to use, the large one or the small one? How about this? Use a large one and plug this in and see what happens. Position is equal to half at squared, which right here you know is going to be minus 9.8 t squared plus vot. Where you have initial velocity vo, you can put 9.8 t and then you have a t. And see what would happen. You will have here a minus 4.9 t squared plus 9.8 t squared, which if you combine, because these are like terms, you'll get 4.9 t squared, which is exactly the same as half a t squared or half gt squared. This 4.9 t squared is exactly the same as this. Think about it, 9.8 divided by 2 is 4.9. So in this particular instance, you can get away with the easy formula, and that's what you should go for. How do I know what to put in place of s? Your position is right here. Maximum height is 50. 50 is equal to half acceleration minus 9.8 t squared. You can view this as a positive, so you don't end up seeing a situation where you're doing a negative. You're not doing a square root of a negative number, so you can make this into positive. You'll do 50 times 2 divided by 9.8. You'll square root it and you get the time 3.19 seconds. T is equal to 3.19 seconds. Now, how do I find that initial velocity? VO, you just look right over here and plug it right here. 9.8 times that time, 3.19 seconds. I have this value already saved. I'll multiply by 9.8 and I'm getting 31.3. This 31.3 represents your initial velocity. If you throw a ball with an initial velocity of 31.3 meters per second, you'll reach the maximum height of 50. Now, how do we check if our answer is right? We come right here to the long equation and plug in all our variables. We have a, which is 9.8, we have time, which is 3.19, we have initial velocity 31.3. All of those, plug it in. Let's plug the values in. I have time, which is 3.19, and I'll multiply by my acceleration, which is minus 9.8. I'll divide it by 2. I'm getting a minus 49.86. From here I'm getting a minus 49.86, and I'll add it to 31.3 times 3.19. Plus 31.3, your initial velocity times time 3.19, and I'll get a value close to 50 meters, which is right here, so we know our answer is right. So this is exactly how you do this type of question. You have to know at the point where the ball changes direction, the final velocity is 0, because the ball will briefly stop in time before it changes direction from up down. And that right there will help you in to determine this factor, which you can plug right here to come down to this equation. You solve for time, then you come back here, you solve for your initial velocity, and you're good. Everything has been completed for you. Thank you for watching.